Hello, class. Welcome to the next lesson in Module 3 for Eureka Math. This is Lesson 14, talking about the converse of the Pythagorean Theorem. It's on pages 157 through 166 in your Module 3 workbooks. We are through this is the last lesson in the third module of 8th grade math, so we've been working a lot so far this year. And we've talked about the Pythagorean Theorem a few times. I think this is the fourth lesson we've had about the Pythagorean Theorem. And so far, on the road so far with the Pythagorean Theorem, we learned how to use the Pythagorean Theorem. And here it is in parentheses, the Pythagorean Theorem. I hope you have it memorized by now. A squared plus b squared equals c squared. We learned how to use that to find side lengths in right triangles. So in Lesson 13 and in a couple lessons at the end of Module 2, we talked about how to use the Pythagorean Theorem to find a missing side of a right triangle. Remember, Pythagorean Theorem is true for only a right triangle. So we found out how to, if we have the two legs of the right triangle, we can find the hypotenuse. If we have the hypotenuse in one of the legs, we can find the other leg. That's the straightforward, that's the forward way of using the Pythagorean Theorem. Today in math, we're going to do what's called the converse of the Pythagorean Theorem, or kind of in the reverse. So far we've been finding a missing leg of a right triangle. Today, we are actually going to get we're going to get three sides of a triangle and prove that it's a right triangle. So far, like yesterday, we started with a right triangle and we found all three legs. Today, we're going to do the converse, kind of the reverse. We start with all three legs and we say, yes or no, is it a right triangle? So you know how to start with a right triangle and find the legs. Now we start with the legs and see if it is a right triangle. So we are going to use the theorem in reverse. We take the side lengths, put them in the theorem to prove a triangle is a right triangle. So this is how we prove if something is a right triangle. This is how we prove if something is perfectly perpendicular and hits at a 90-degree angle. That's a little paragraph about what we're doing today. I do have it in other words. In other words, if a squared plus b squared equals c squared, if both sides are equal, then it is a right triangle. If a squared plus b squared does not equal c squared, if the sides are not equal, it is not a right triangle. So that's what we're doing today. If the Pythagorean Theorem is true, it is a right triangle. If the Pythagorean Theorem does not work, that little equal sign with a slash means it is not true, it does not work. If it does not work, it is not a right triangle. So that's what we're practicing today. If the Pythagorean Theorem works, we have a right triangle. If the Pythagorean does not work, it is not a right triangle. So basically today we are going to be testing triangles to see if they are right triangles. And the test we will use is the Pythagorean Theorem that you know already. So I think today is pretty straightforward. I think you should understand today's work pretty well. Take a minute, maybe pause this video, go back and fill in some of the notes you might have missed if you need to go back and watch the videos. Take some time to finish copying down the notes, and then unpause the video when you are ready to do some examples, when you are ready to test some triangles with the Pythagorean Theorem. Hopefully you took a minute to review your notes and get all your supplies ready. One thing I forgot to say, I think, is a calculator would be super useful in today's work if you do not want to do the multiple. There is going to be a lot of multiplication today and addition. So if you don't want to do all that on paper, maybe you can have a calculator sitting next to you so that the calculator can help you with the multiplication today. I'll be using my calculator out for the example problems. It is okay if you use your calculator today also. So if you want to grab a calculator, go ahead. If you have a calculator on a phone, that'll work. But let's get started on page 157, the first page of our practice, which looks like this, page 157. We have, I think, 7 exercises for practice. So let's look. Number 1, and I think I'm going to read the directions once, because I think the directions are the same for all 7 exercises. The numbers in the diagram below indicate the units of length of each side of the triangle. So these numbers tell you how long the sides are. The numbers tell you how long the sides are. Is the triangle a right triangle? Is the triangle a right triangle? Okay. Show your work and answer in a complete sentence. We can do that. Okay, so first of all, this is a triangle, but we do not know if it is a right triangle. Now, where could the right angle be? The right angle looks like it might be here. This is a maybe. We do not know if it is a right triangle. We can guess that that's the right angle. So we need to use the Pythagorean theorem to test it. And so remember, the Pythagorean theorem is a squared plus b squared equals c squared. Now we need to find a, b, and c. Now for this one, remember in the other lessons, I told you that the legs are next to the right angle and the hypotenuse is opposite the right angle. Well, in these triangles, we might not know where the right angle is. We don't know if there is a right angle. So in this one, how do we know where the legs are and where the hypotenuse is? If there's no right angle, how do we know the hypotenuse is where the hypotenuse is? Because the definition of hypotenuse is it is the opposite of the right angle. But if there is no right angle, how do we know? Well, here's a little trick. You probably noticed this. I think you noticed this, and it makes sense, but I don't know if you actually remember it in your head or if you even thought about it. But the hypotenuse in a right triangle, the hypotenuse, C, is always the longest side. The hypotenuse is always the longest side. It makes sense because if you look at the Pythagorean theorem, the hypotenuse, which is C, is the other two added together like this. So you know C has to be bigger than the legs because the legs add to make the hypotenuse. Now it makes sense. I just don't know if you realized that. So that is a true fact. You have to remember that because you need to know it for the work today. The hypotenuse is always the longest side. So if we have a right angle, we know the hypotenuse is opposite the right angle. But if we don't know for sure, if we don't know for sure, if it's a question, we always find C because C is the longest side. So when we have 9, 12, and 15, we know 15 has to be C because it is the longest. So, and then A and B, it really does not matter which one is A or which one is B. I'm going to say A is 9, but if you want to say A is 12, that's okay also. You will get the same answer whichever one you pick, A and B. The only one that is different, the only one you find first is C, the hypotenuse, because it has to be the longest one. Some people are going to mess up on today's work because they're just going to pick A, B, and C randomly. A, B, and C cannot be random. C is always the hypotenuse, and the hypotenuse is always the longest side. So C has to be the longest side. I think I've said about 7 or 8 times right now. It is that important to remember because I know I said it 7 or 8 times and there are still people who are going to forget. C, the hypotenuse, is always the longest one. But after you find C and you label A and B, you're ready to check the triangle with the Pythagorean theorem. So we have the Pythagorean theorem. A is going to be 9 squared, plus B, which is 12 squared, equals C squared, and C is 15. So after we substitute, we get this. Now we have to do the math, and this depends on, and this time it's a test of how good you are at your math facts. You know 9 squared is 9 times 9, 12 squared is 12 times 12, 15 squared is 15 times 15. So how many of these do you know? Well, 9 times 9 you should know is 81. 12 times 12 is 144. 15 times 15 is the one you might not know, but you might want to get your calculator for it. But I'll tell you 15 times 15 is 225. So now we need to now we add the A and the AB side, 81 plus 144. And well, I know it, but just to prove for you, just in case you do not trust me, 81 plus 144 is 225. Oh, I have a little bit of a glare. 225 right there. So 81 plus 144 is 225. So now this is equals to 25. This equals to 25. The Pythagorean theorem is true. So, is the triangle below a right triangle? It is a right triangle because the Pythagorean theorem is true. It stays true. 225 equals 225. Check. So this is a right triangle. We can put the right angle right there. We can cross out the question mark because now we know for sure. So that was the first triangle we tested. Let's test another one. Let's test number 2. I'm not going to read the directions again because directions are the same. Test the triangle to see if it's the right triangle. And we are going to use the Pythagorean theorem, which again is a squared plus b squared equals c squared. First thing you do, remember we do not pick them randomly. Do not just pick randomly. Label them. Label them. And remember, always start with the hypotenuse. And the hypotenuse, C, is the longest one. So we have 3.5, 4.5, and 4.2. 4.5 is the longest one, so that is C. It has to be. It's the longest one. A can be that one, B can be that one. It really does not matter which one is A and B. That's just what I picked. You can switch A and B if you want. But C has to be 4.5. So we wrote the Pythagorean theorem. We have our letters labeled. We have the variables labeled. Let's put the numbers in for the variables. So A is going to be 3.5. So we have 3.5 squared. B is 4.2. And C is 4.5. Now squared means multiply by itself. So we do 3.5 times 3.5 plus 4.2 times 4.2 equals 4.5 times 4.5. Now this is where you might want to get your calculator. So if you get your calculator, let's do 3.5 times 3.5. We get 12.25. Glare. I'm sorry about the glare. Then we do 4.2 times 4.2. And we get 17.64. Then finally, we do 4.5 times 4.5. And we get 20.25. So that's what we do after we get the squared. Now the next step is adding this side together. So we take the 17.64 and we do plus 12.25, and we get this side is 29.89. But over here we still have 20.25. Now those sides are not equal. They are not. 29.89 does not equal 20.25. So this one, it cannot be a right triangle, because right triangles have to follow the Pythagorean theorem. This one does not follow the Pythagorean theorem. It fails the Pythagorean test. So it is not a right triangle. The Pythagorean theorem does not work for this triangle. Pythagorean theorem does not work for this triangle, so it is not a right triangle. So in example 1, exercise 1, the Pythagorean theorem was true. It is a right triangle. Example 2, Pythagorean theorem is not true. It is not a right triangle. We're going to do some tests right now. We're going to keep going. There's a few more triangles we're going to test. Feel free to work ahead or to pause the video while I pause the video and do the answers yourself to see how many you can get on your own. And then you can start the video again when you're ready to check your answers with mine. But I am just going to keep going. For my live lesson people, the people who are watching this live, if you want to go faster than me, you can go faster than me right now. And we'll talk about all the answers when I'm done, but I'm going to just keep going. We're going to talk about all of these. And let's go. Let's start with number 3. Let's keep going. Remember, if you want to work faster than me, go ahead and work faster than me, and you can check your answers when you're done. So we're going to check this triangle with the Pythagorean theorem, and I need to find my variables. I know C, the hypotenuse, is the longest one, and that is 170. And for the other ones, it does not matter which letter I pick. I'm just going to make one A and one B. If the longest is C, I'm good. So A was 72, B was 154, and C was 170. So now I need to put these into my calculator. 72 squared, 72 times 72, works out to be 5,184. 154 times 154 squared, ends up being 23,716. And yes, I am using my calculator on this, so it is okay if you use your calculator to do these. C squared, 170 squared. 170 times 170 works out to be 28,900. So we got some pretty big numbers right here. So now the next step is to add this side together. So we need to do 5,184 plus 23,716. When we add them together, you get 28,900. Which, guess what, is what the other side equaled. So this time the Pythagorean theorem is true. It is, for number 3, the Pythagorean theorem is true. So we can say this is a right triangle. Okay, another test. So we've tested 3 triangles so far. 2 have been right triangles. one has not been a right triangle. Because this is a right triangle, I'm going to add the little right angle box right there, because I can add it now because I checked it. I proved it. This is a right triangle, so I'm going to put the right angle there. If you look at number 2, I did not put the right angle because it's not a right triangle. Let's look at number 4 now on page 158. Let's test this triangle. Now, this triangle might be a little bit tricky to see. This is why I told you that hint about the hypotenuse. We are still going to use the Pythagorean theorem to test this, so we still need a squared plus b squared equals c squared. But for this one, it might be a little bit tough for you to figure out where is the hypotenuse, except I told you, see, the hypotenuse is always the biggest number, the biggest side, the longest side. So we have 9, 40, and 41. You know C has to be 41 because 41 is the biggest number. I'm going to just pick A and B. So now we have all 3 labeled. And remember, I'll say it again because I need you to remember. The hypotenuse is the longest one. A, I said, was 9. B, I picked 40. And C has to be 41. Now we plug all of these numbers into the equation and we start solving. So we get 9 squared is 9 times 9, which is 81. 40 squared might be a little bit more complicated, but 40 squared, you type in your calculator, you get 1,600. 41 squared, I'm using my calculator, is 1,681. What do you know about that? If I do 81 plus 1,600, I get 1,681. And so I use the Pythagorean theorem, and it works. It is true. So this is a right triangle because the Pythagorean theorem is true. And in fact, I can even draw my little box here. The right angle goes right here because it is opposite the hypotenuse. So this is a right angle. It is true. There's the right angle right there. This is a right triangle. I just proved it with the Pythagorean theorem. So now, so far, we've done 4 triangles. 3 of them are true, and 1 of them is not. Let's see what the number 5 is going to be. Number 5, same directions, same everything. We're testing to see if this is a right triangle. And the test is using the Pythagorean theorem. Now we need to find our different variables. Remember, we find C first because C is the easiest one. C, the hypotenuse, is the longest one. I don't know how many times I've said that today. Hopefully you remember it forever. The hypotenuse is the longest. So because 36 is the biggest, that's going to be C. I'm just going to pick A and B. I'm going to put my numbers into the equation, into the Pythagorean theorem. 10 squared I can do without my calculator. 10 squared is 10 times 10. I know that is 100. For 34 squared, I'm probably going to want my calculator for this one. So I'm going to do 34 squared, 34 times 34, 1,156. Then I need to do 36 squared. 36 squared is 1,296. Now I need to add these together. Well, 100 plus 1,156 is just 100 bigger. So this is going to, instead of 1,156, it's going to be 1,256 on the left side, and on the right side I have 1,296. Those, it's a 56 and it's a 96, not equal. The Pythagorean theorem is not true. This triangle fails the test. So this is not a right triangle. It fails the test. So I am not going to put the right angle box here because it is not a right triangle. Now, if you just look at this, this looks like a right triangle, but it's not. Is it close? Yeah, it's pretty close. 1,256 is pretty close to 1,296. But if it's a right triangle, it will be exactly the same. So even though it looks like a right triangle, it's not. It's close, but it's not. Don't just do what it looks like. You have to do the math on the test. Looks can trick you. This looks like a right triangle, but it is not. Do not let the looks trick you. So we've done 5 triangles. 3 are right triangles, and 2 are not right triangles. Let's see if number 6 can tie it up with 3 right and 3 not right. So we are going to use the Pythagorean theorem for our test. So I'm going to write the Pythagorean theorem again. And again, I need to find my hypotenuse. And remember, the hypotenuse is the longest one. So for this one, the hypotenuse is 7, because 7 is the biggest side. And then I'm going to label A and B. I'm just going to, you can switch those if you want. That's how I did it. You can do it differently. But C has to be 7 because 7 is the longest side. Let's put them into our equation. A is 2, B is 6, C is 7. Now, all of these numbers are small enough where I know my math facts. I can do this. 2 times 2 squared is 2 times 2, which is 4. 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which is 49. And then I do 4 plus 36, which makes 40. And then, obviously, you guys know 40 does not equal 49. They are different. They are not equal. So this is not a right triangle. 40 does not equal 49. The Pythagorean theorem is not true for this triangle. So this triangle is not a right triangle. So we've done 6 triangles. 3 of them had a true Pythagorean theorem. 3 of them had a Pythagorean theorem that did not work for them. So we have a tie, 3 and 3. But we have one more triangle to test. Let's see which one's going to have more. Let's see if our exercise will have more right triangles or more not right triangles. So let's go to work. We're going to use the Pythagorean theorem test again. So a squared plus b squared equals c squared. And I need to find a, b, and c. C is the easy one. C is the longest one. 6.5 is the biggest number. It is the longest side, so that has to be C. A and B, I'm just going to label like that. They can be switched if you want. Let's substitute. We get A is 2.5, B is 6, and C is 6.5. Now, I believe 2.5 squared is going to be 6.25, but let me check it with my calculator because I want to make sure I don't lie to you. And 2.5 squared is actually 6.25 because 2.5 times 2.5 is 6.25. 6 squared I can do in my head because 6 squared is 6 times 6, and that is 36. 6.5 I unfortunately do not have memorized, but 6.5 squared, 6.5 times 6.5 is 42.25. Now I need to add this side together, so I do 6.25 plus 36, and I get 42.25 on this side, and I have 42.25 on this side, and these sides match. This is true. 42.25 does equal 42.25. So I can add my right angle box because it is a right triangle. And I write down that this is a right triangle. So the final score, excuse me, After 7 exercises, 7 triangles that we tested, 4 of them were right triangles and 3 of them were not right triangles. So if you did work faster than me and you're back to check your work, let's check them again. Exercise 1 was a right triangle. Exercise 2 was not. Number 3 was. Number 4 was a right triangle. Number 5, not a right triangle. Number 6, not a right triangle. But number 7, the tiebreaker, is a right triangle. So we have 4 right triangles, 3 not right triangles. All solved, all discovered using the Pythagorean Theorem test, using the 3 sides. Go back and check your work with mine. If you need to go back and rewind the video, pause the video, check your work, finish up any work you have. When you are done checking, and if you need, also if you need to send me a message because you are stuck or you are confused, this is a perfect time to pause the video, send me an email, ask for more help, and I will definitely help you. But you can pause the video right now, check your work, finish up all 7 examples, and when you unpause the video, we will talk about today's problem set and exit ticket. Okay, you should have checked your exercises 1 through 7. You should have reached out to me with any questions you have so that I can help you. I might have gone a little fast. I hope I did not go too fast. I hope you understand this. It is pretty straightforward. You're just using the Pythagorean theorem to test triangles. But if you understood all that, great. Let's start talking about your independent work for today. So you'll see the lesson summary on page 159, which is just saying that if the sides satisfy the Pythagorean theorem, it is a right triangle. Satisfy is another way to say makes it work. I guess you could say if you are satisfied, you're happy. So the Pythagorean theorem is true. It is a right triangle. If it satisfies, it is a right triangle. If it does not satisfy, it is not a right triangle. Basically, the Pythagorean theorem test. On page 161, you'll see the exit ticket. I'm going to slide that to the back because then we talked about that last. But on page 163, you'll see the homework helper, where if you need a couple more examples to help you with this idea about how to test the triangles, the book was nice enough to give you 2 more examples. And they even tell you what to do right here. They tell you what they were thinking and how they did it. And they have the thought processes here. They tell you the answers. So use the homework helper if you need a couple more examples of what to do. But page 165 is your problem set practice. And remember, for the problem set, my answers will be posted on the Google Classroom. So you can check your answers with my answers to make sure you know what you're doing. The problem set is also a great time to maybe ask me for help. You can email me and I will help you with 1 or 2 of the problem set questions to make sure you know what you're doing. But this is where you get to practice your skills and check your work with my work. Now, normally for problem sets, I tell you which exercises help you with each, but all the exercises are pretty much the same. And if you look at all the problem set questions, all of the problem set questions are pretty much the same. They're asking you to say they're asking, is this a right triangle? So for number 1, 2, and 3, it's just like what we did in the practice. Just put the numbers in the Pythagorean theorem, and is it a right triangle? For number 4, you have to check someone's work. So we're going to check about what Sam did. So Sam said something about this triangle. You need to tell Sam what he did wrong. And you need to tell him what the right answer is. So essentially Sam said that this is a right triangle because 9 plus 32 equals 40. He took 9, he took 32, he did 9 plus 32, he got 40. He says 9 plus 32 makes 40, so this is a right triangle. Sam is wrong. You need to tell me why Sam is wrong, and you need to help him fix his work. The problem set keeps going on page 166. Number 5, same thing, is this a right triangle? Just tell me, is that a right triangle? And for number 6, This time you're going to check Jocelyn's work. Jocelyn said that this is not a right triangle. And she did her work. They show you Jocelyn's work right here. So this is Jocelyn's work. You need to tell me what she did wrong and show her the right answer. So what did she do wrong? Explain what she did wrong. Explain, which means write a sentence or a paragraph about what she did wrong, and then do it right for her. Remember, my answers to the problem set will be on the Google Classroom. After you check your answers and you know what you're doing, you should go back to page 161 and work on the exit ticket. Number one, there's two questions on the exit ticket. Number one is saying, you're talking about Bernadette. Bernadette drew this triangle, and she says it is a right triangle. How can she be sure? How can she be sure this is a right triangle? Explain how she can be sure, and then tell me, is she right? Is this a right triangle? And then number two might be a little bit tricky. This time they do not draw a triangle for you. There's no triangle for number two. They just tell you the lengths. They say, do these three lengths make a right triangle? Explain. So tell me, if you have a triangle with 5, 9, and 14, is that a right triangle? Why or why not? That's your exit ticket. Remember, for the exit ticket, I ask you that you do it, take a picture of it, and then turn your picture in on the Google Classroom. But that is your work today on the Pythagorean Theorem. Hopefully you learned something. Hopefully you know how to test triangles to see if they're right triangles. But that is it. You'll have the next thing you'll do after this lesson tomorrow is you will have a Pythagorean Theorem quiz to see if you have mastered these skills. Have fun working on this. Have a great day. I will see you for the next lesson.